Okay, we're going to continue with the graphing quadratic functions foldable notes. This is going to be flaps 3 and 4. And then you are going to, under the intercept form, flap 3, which is from chapter 5.2. I forgot to have you write that on the front flap, but I'll have you do that now. The formula is y equals a times, in parentheses, x minus p times x minus q. This is just like factored form. And what this is going to give you are x-intercepts, and the x-intercepts will be p0, because you always have a y-coordinate of 0 with an x-intercept, and q0. This parabola that we have here, y equals x plus 1 times x minus 3, which is your factored form, actually does have an a. It's 1. It's right there. You don't see it, but it is there. So the parabola opens up. Now, just like with most of the situations, with all of your parabolas, all your methods here, all 4 of them, you will see that they all have an a, so you can determine whether the parabola opens up or down. You will also notice that you're always calculating an axis of symmetry, albeit differently in some situations, but you're always calculating that axis of symmetry. And the formula for calculating the axis of symmetry is p plus q divided by 2, and I'll go over why that works in just a few minutes, but let's get the picture drawn first. You first have to determine what your p is and what your q is. Well, p is in the pattern x minus p, so since it's x plus 1, then p is negative 1. And q is in the pattern of x minus q. Since it's x minus 3, you're good, and it's just 3. So this is a lot like finding a midpoint, if you remember how to do that. We're finding the middle. The axis of symmetry divides the parabola into equal halves. So you would have x equals negative 1 plus 3 divided by 2. So x equals 2 divided by 2, and therefore x equals 1. Okay, we're going to go ahead and highlight that. So x equals 1. Now we're going to go ahead and draw that in. So we're going to put in our x equals 1. That's our axis of symmetry. We're going to label our axis of symmetry with its equation, x equals 1. The next step, and this is frequently the case, you're going to calculate the vertex. The nice thing about this is you have x, and right here you have y equals x plus 1 times x minus 3. So that x is simply going to go into this x position and this x position. So it's going to be y equals 1 plus 1, and then times 1 minus 3. You can use the additive inverse if you want to, add the opposite, or you can just do it mentally. It depends on your skill level. 1 plus 1 is 2. I'm going to just do it mentally. 1 minus 3 is going to be negative 2. And so y is going to equal negative 4. So our ordered pair, we already knew our x value. So we'll put that in here. It was 1. Now we know our y value, which is negative 4. So 1, negative 4 is the vertex. So we're going to plot 1, negative 4. And now that gives us 1 point. So we're going to need to now go ahead and get 2 other points. Well, since this is the intercept method, we can get 2 points right on the x-axis, and then your midpoint's going to make a lot more sense here. So 3 is to find and plot the x-intercepts. Now there's a couple of ways to do this, and I'll talk about how you could have done it, but I think finding the zeros of the function is a little bit easier, and that means finding where the x-intercepts lie on the x-axis. So I think find the zeros of the function. You use the zero product property. To find the zeros of the function, you use the zero product property. I think that's the easier way to go about this. A little trouble getting step 4 in here, but we'll do our best. Okay, so when you find the zeros of the function, you simply say, when I have y equals x plus 1 times x minus 3. If either one of these were 0, when you multiply anything times 0, it comes out 0. And so if the first one were 0, which would be negative 1 plus 1, then it'd make the whole thing 0. If the second expression were 0, which would be 3 minus 3, so x would be 3, it would make the whole thing 0. But here's how you, when you have a more complicated problem, this one you could do mentally, but when you have a more complicated problem, you would say, what would x be in the first binomial? So y equals, I'm sorry, never mind. X plus what would equal 0? And then your second one would be x minus 3. What would x be to equal 0? This is your zero product property. And this is just simply finding the zeros of the function. And so we would subtract 1 from both sides. And x would equal negative 1. And that ordered pair would be negative, because this is an x-intercept. Since this is an x-intercept, the ordered pair would be negative 1, 0. And then we go here, finding the 0, we would add 3 to both sides. And so x equals 3, and so the ordered pair would be 3, 0. Now, if you remember earlier, we'll plot this in just a second, that the x-intercepts would be p0 and q0. Well, we determined in axis of symmetry that p was negative 1, so negative 1, 0, and then q0 would be 3, 0. So that's another way to do it, but if you forget and you're uncertain as to whether it's positive or negative based on this, you can always do the zero product property and find the zeros of the function. So we have negative 1, 0, labeling it. We have 3, 0, labeling it. And remember, I talked about when you do the midpoint, or the axis of symmetry, it's effectively the midpoint. So it's p plus q, the x coordinates divided by 2. So if you look at this now, you can see that this 1, 0 is 2 from the axis of symmetry, and that this 3, 0 is 2 from the axis of symmetry. So effectively, what you found, x equals 1, or 1, 0, is the midpoint of the two x-intercepts. Okay, we still need 2 other points, and I'm a little bit short on room, so we're going to need to box off a certain area. Let me pause it and get that area set. Okay, I went ahead and put step 4. You'll be able to go below, but I had to go to the side. We're going to calculate one more point and reflect it. So we need to choose something that is to the right or left of the points we have, or we could, in fact, just go to the right or left of the vertex. We don't have to go to the right or the left of the x-intercept, and I could choose 0, which is always such a lovely point to choose. So we put in 0 to the equation, so x is going to be 0, so y equals 0 plus 1 times 0 minus 3. Y equals 0 plus 1 is 1, 0 minus 3 is negative 3, so 1 and negative 3. 1 times negative 3 is negative 3, so y equals negative 3. So the ordered pair is 0, negative 3. So we're going to go ahead and plot that. So 0, negative 3. This is our y-intercept. And then we're going to reflect 1. So we have 1 from the axis of symmetry on the left. We go 1 to the right, plot our point. And that's going to be 2, negative 3. So the reflected point is 2, negative 3. And we're going to connect those with those points together to form our parabola. All right, now we're going to move on to flap 4, which is the vertex form. Okay, in the vertex form, flap 4 is y equals a, that's the leading coefficient, times x minus h in parentheses squared plus b. And our vertex is hk, and our axis of symmetry is x equals h. So the problem that we're going to put in our notes underneath the fourth flap is y equals negative, which you could also write negative 1 if you wanted to, in parentheses x minus 2 squared plus 3. And then I've put in red what h is. It's negative. It's going to be 2 because the pattern is x minus h, so x minus 2 means that h is 2. And the pattern is plus, oops, it's not b, my fault, let's fix that. It's plus k. Let me stop and 3 is k, and since it's plus k, then k equals 3. So the first thing that we're going to do again is draw the axis of symmetry. So 1 is the axis of symmetry as x equals h. And since x equals h and h is 2, we already determined that right here, then it's going to be a vertical line at 2. So we're going to draw that in. That's going to be our axis of symmetry. And our equation for that is x equals 2. All right, now we move on to the second step, which almost always is the vertex. Sometimes people do the vertex before the axis of symmetry, but that's fine, we don't need to. So the vertex, we know from up here is hk. So it's h comma k. And we know that h is 2. And we know that k is 3, so it's 2, 3. There's a vertex. We're going to plot that. So 2, 3. We also know from this a, since a is this negative or negative 1 out here, that a equals negative 1, and so it opens down. So our parabola will be opening down. All right, we now move on to step 3, which is to pick a couple of points. So we're going to pick 2 points. Actually, pick 2 x values would be better. Pick 2 x values to create the points. And we'll go ahead and show that work. This is just your x values. Your x values, which are your 0 and your 1. And so we're going to go ahead and put our 0, our x value, into that equation, negative times x minus 2 squared plus 3. That's the one we're putting into, y equals a times, or excuse me, let's not put the a in this time, negative 1, I'll stick the negative 1 in, times x minus 2 squared plus 3. Okay, so that'll be nice and easy. So we go y equals negative 1 times negative 1 times our x of 0, 0 minus 2 squared plus 3. So y equals negative 1. 0 minus 2 is negative 2 squared plus 3. Negative 2 squared is 4 times negative 1 is negative 4 plus 3. So y equals negative 4 plus 3. So negative 4 and 3 is negative 1. So the ordered pair is 0, negative 1. So we have 0, negative 1. That's a y-intercept. We're labeling it 0, negative 1. And as always, that fourth step will be to reflect the 2 points in 3. And you have 0, negative 1 reflecting it, 1, 2 from on the left side of the axis of symmetry, go 2 to the right side of the axis of symmetry, which gives you the point 4, negative 1. And then we're going to pick another point to the left, and I can pick 1 because it's right here. It's in the left side, so I'm going to pick 1. And so y equals negative 1 times 1 minus 2 squared plus 3. Y equals negative 1. 1 minus 2 is negative 1 squared plus 3. Negative 1 squared is 1 times negative 1 is negative 1 plus 3. And negative 1 plus 3 is 2, so the ordered pair is 1, 2. So let's plot our 1, 2, label it, and then we're going to reflect it. So we are 1 from the axis of symmetry on the left side at 1, 2, so we are 1 to the right side of the axis of symmetry. Plot our point. It is 3, 2. And we're going to write that here, 3, 2. And then we are going to connect our points with the parabola, and there is your graph. Make sure these notes are completed. You'll have over a two class period time to complete them, but they will be helpful on any kind of quizzing and for studying. It shows the relationship between the 3 methods of graphing a quadratic equation.